Good afternoon, students. Good afternoon, students. This is a power system analysis to 7th semester. Myself is B N Patil, Assistant Professor of Department E&D Engineering, Angadi Institute of Technology and Management, Samagam Road, Belagavi. The first model, total 5 models. The first model, load flow studies, model number 1. Model number 2, load flow studies continue. Model number 3, optimal system operation. Model number 4, optimum system operation continue. Symmetrical fault analysis. First I will explain load flow studies. What is the importance of load flow studies? The generation supplies demand, that is a load plus losses. Bus voltage magnitude remain close to the rated value. It means the load plus losses equal to bus voltage magnitude remain close to rated value. The generation operates within the specified real and reactive power limits. Always generator operates within the specified real and reactive power limits. Always voltage in PU 0.9 to 1 PU. The same thing, the real power and reactive power within the limits, generator limits. Here the transmission line and transformer are not overloaded. Here the different types of buses. First one is a load bus. Second one is a voltage controlled bus. Third one is a slack or swing bus. First I will explain load bus or PQ bus. First, what is a load bus? Bus at which active power and reactive power are specified. Here the always 4 quantity, 2 quantity is given, specified, remaining 2 quantity will be calculated. That is load flow studies. Here the buses at which active power, reactive power is specified. The remaining magnitude of V and phase angle of delta voltage will be calculated using load flow equations. This type of the buses are most common, at least 80% of the buses are given in the power system. Next, slack bus. Slack bus is a reference bus. Always bus number 1 is a slack bus. It is a reference bus. Voltage magnitude and voltage phase angle will be given, specified, and real and reactive power will be obtained. Here the 2 quantity again same, V and angle will be specified. The remaining real and reactive power will be calculated. That is generator bus is a slack. Why the generator bus will be slack bus? Because of generator itself you calculate real and reactive power have to be calculated. Normally there is only one bus of the given the power system. One generator bus is selected as a reference bus. Already told no, one generator bus is selected as a reference bus. Here slack bus voltage angle and magnitude is normally considered as 1 plus J0. That is a flat voltage profile. It is itself as a 1 PU. That is J will be 0. That is 1 plus J0 PU. Just write given just table plus classification table. Here a type of the buses. Type of the buses. Specified. V will be specified. Angle will be specified. P and reactive power will be calculated. Slack bus. The same thing in load bus. P and angle will be unknown. The remaining real and reactive power will be specified. The second bus, PQ bus, already explained. The 2 quantity will be available. The remaining 2 quantity will be calculated as V and angle. Third one is P bus, that is generator bus. The P will be given. The angle is unknown. You calculate. That is P is given. V is given. Just to calculate unknown value, angle and reactive power. The next static method. The following variables are associated with each bus: V, angle, P and Q. That is magnitude of the angle, phase angle of the voltage, active power and reactive power. The next, the load flow problem can be solved with the help of load flow equation. That is static load flow equations. Here first you calculate I equal to Y into V. The same thing, I equal to Y bus and V bus. I equal to Y bus, V bus. I equal to Y bus and V bus. Just equations. What is I1? Just to multiply it, Y11 equal to V1, Y12 equal to V2, Y1 equal to 13 equal to V3. That is I1, I2 and I3. Just bus number 2 and 3 you can write. Bus number 1, that is Y11, just multiply with the Y and V. Y and V. I1, I2 and I3. Next that is I1 equal to, that is I equal to Y bus into Y bus. Summation of the Y bus into Vk. I k equal to 1, 2, 3 n, the complex power. What is S? Power. That is P I J Q I. That is P Q I is a per unit real power and reactive power. Per unit real power and reactive power. Next, what is I? I1 star, that is a P1 JQ1 V1. I1 equal to P minus JQI by V I star. That is P JQI VI, that is summation of Y into V. Finally, P equal to V into I. Here Y Ij Vj Ij, that is bus of Ij. Let's Polar form, you calculate Ij angle. That is V with respect to the angle. The equation of written as P JQ Y into V angle of theta Ij del J minus del I. That is difference between J and I angle, that is J minus I. The real and reactive power will be expressed. Just you calculate Yj Vj Ij. That is finally Vi equal to P equal to Vi. That is active real power and reactive power equations. Next, approximate methods. The simple and approximate solution can be made by following assumptions. Some assumption will be made because small line resistance are related, which the means the active power loss line is be 0. Next, voltage measured the various must be within the limits. Active and reactive generated power at different. Active and reactive power at different buses, that must be within the limits. The total power generation must be equal to the load bus losses. The system stability considered will impose the limit on the maximum value of delta. All buses other than slack bus, PV buses, that is voltage bus. The magnitude of all buses including slack bus are specified. The angle of delta is so that sin del I equal to del I. These are the assumptions. The above equation can be written as again same equations, just to minus because of you calculate minus reactive power P minus JK within the same. Already explained V I K O I K I minus K. Previous this is a J, here K I equal to 1, 2, 3 and